You get what I mean?
Yes,
For
yes.
example,
Yes.
if I want to create a character array, character
Yes.
codes. Okay, so there are some codes,
Yeah.
right?
Yeah.
Let's say, okay, uh, 8 codes. Okay, and then I can give some codes, maybe J, then 6, then K, okay, stuff like that.
Yes.
My point is,
Yeah.
when you make an array, you can only make it of the same data type.
Yes.
Okay,
Yes.
let's make it 4. Okay, so this is basically a character array. Okay,
Yeah, yeah.
previously what I made was an integer array.
Integer array.
Okay, now what I'm going to do is, basically I'm just going to make so I'm going to make a data structure which is going to contain other data types as well.
Okay.
Okay, that is called as a struct.
Okay.
In C, right?
Yes.
Suppose if in a hospital a patient is coming in, let's say,
Yeah.
right?
Yes.
You would need to take his name, you would need to take his age, okay, you would need to take his gender,
Yes.
okay, his or her gender, you would need to take his or her phone number, right? So there are multitude of data types, right? Not just numeric, but non-numeric as well. Yes?
Yes.
Numeric also you will have, non-numeric also you will have, right?
Correct.
Age is a numeric data type.
Yes.
Gender is a non-numeric data type. Like the different things you will have to take for a patient.
Yeah.
What then? How to store multiple data types then? So for that we use what is called as a structure, or struct basically. Okay. So struct. Okay. So I define a struct called person, let's say, curly bracket open. So for this person, I'm going to give 2 things. Okay. Int age. Okay. And character gender. So what am I defining for this person? You tell me.
Okay, declaration you have done is a struct person. No. That is the main function. Struct person is the main function, no? Like you write int main.
So what I've done is just the declaration of the data type.
Okay,
so a blueprint for the data
but you have not written in. You have not written struct main. Main you have not written main. Main function.
No. Main, inside main. Okay, I will show you what we will do.
But you have not even written main, no?
In fact, I've written it outside main. Yeah, I've not even written main.
Yeah, that is what I was.
I've written it outside main. If you see.
Correct. So you don't have to write main. It's not compulsory.
So for this you don't have to write.
Okay.
Okay.
So struct person is the declaration. Struct person.
Right. Simply it's just a blueprint for some kind of a data structure, complex data structure. Blueprint of one complex data structure.
Okay. And so there is the declaration is int age, character, gender.
So two things I'm giving for this structure. One is an integer, one is a character, right?
Yeah.
Why the integer?
Integer is for age, no? You can't write in character. You can write in characters.
Suppose if we do happen to create any variable for this data structure, I want the integer, one integer which will be called as age. I want one character which will be basically gender, right? Yeah. So we will do that now. So how I declare a variable for this blueprint you see now. First I write struct, then the structure's name. So the structure's name that I had given was person, right?
Okay.
So the structure's name, person, and then I will say P1.
Okay. Yeah.
That will be the declaration of a variable of said structure name. Okay. So what we have to call? We have to call struct. Then we have to say person, which is the name of the struct basically. See, because struct is a general keyword. Which helps us to define a particular structure, complex structure, right? A complex structure may have different data types inside it. It may have integer, it may have float. I could have created one more, which is a float, right?
Yes.
I could have done that. But in array, you can only create an integer array or a float array, right?
Yes.
You see the problem? Yeah.
In array you can create float also. Float array and integer array both together you can mix.
No. But if I create let's say if I create an array of the float type, right?
Yeah.
I can only give float elements.
You can't put integers. Yeah.
Right. Let's say temperature.
Yeah.
Okay. I create an array for temperature. So temperature can be 29.5, 30.6, like that, right? It's decimals.
Yes.
So 10, let's say, or 7, let's say. I store this week's temperature I store, let's say.
Yes.
Okay. Okay. Here I will be allowed to only store floating points. Okay.
Understood, sir. Yeah. So struct P1 is the declaration. Struct person P1.
Person P1, which is one variable we are creating. Okay. So what will I give? Okay, P1 dot, I will give the age. P1, for the P1,
yes.
I do dot.
Yeah.
Okay, I put dot because, see, P1's age I have to now declare, right?
Yeah.
How do I access the age of P1? So I have to put a dot here. Okay, so P1 dot age equal to, let's say, 30.
Yeah.
Okay, now inside printf, let me put within double quote percentage. So age, is it a integer?
Age is an integer. You can write it as float also, but integer is better.
Integer, yeah. Here we have declared it as an integer.
Yeah.
So I have to give percentage d in order to see it, right?
Okay. Yeah.
P1 dot age. Simply I put P1 dot age.
Okay.
Okay. So I assigned it here. What I did is, it did not, the P1, it did not have any values. So I assigned it here. Okay.
Correct.
And then now I am printing it.
Yeah.
This is assignment, and this is basically display. Okay. So I will run it. 30.
Declaration, blueprint, declaration, assignment, printing, display.
Yes.
If I want to write comments, yeah.
This is the display. Yeah. Blueprint. So for blueprint, you can do it independent of the main.
Yeah.
You are just creating a blueprint for some structure, right? As your own.
Yes.
You can do it before main, whatever you want to create. Like I can create another structure.
Yes.
Can you tell me? I can create another structure called patient.
Yeah.
Right? As we discussed, patient, and it could have multiple.
Patient is better than person.
Because it will have multiple things. I know.
No, because that makes more sense in this. If you're taking the case history, or like if you're recording the details of the person, of the patients, then patient makes more sense. That then you immediately understand. This is a hospital. Okay.
So basically, and we will also understand that we are making a structure for a hospital record.
Yeah, hospital records, correct.
Yeah. You're right. This is just a general registry. Okay. Let's say the national registry of, for the statistics and all purpose. Right. So let's say a person whose age and whose gender we know, like that.
Yes.
Okay.
Yes.
Yeah. Of course, we need to know the name also, but so for now, I'm just showing these two. Yeah.
Yes.
So this is how you create a structure, right?
Okay.
So now what I will do is, so bear with me.
Yeah.
So what I will do is, I will just tell you the definition, which I want you to write down.
Yes.
Okay. So I will tell you a definition, write down.
Yeah. This, if you can just copy it, and paste it in this thing, paste it in that WhatsApp,
okay.
Yeah. Then I will print it out and keep it as a record, yeah.
Okay, I will,
Because this is something new, that's why. Like character, struct is also new. So if somebody mentions struct, then I immediately will understand, this is the structure. You're giving me the definition of structure, of struct.
Yes.
Yeah.
No. I'm giving you the definition of abstract data type. Okay. So which is read it, you'll understand.
All right.
So you see, with this data structure which we created, right?
Yeah.
Okay. Struct. That is person.
Yeah.
Okay.
Yeah.
Did we define any sort of operations with the struct.
Like plus this, that minus, multiplication. Yeah.
Because when it comes to integers, you can actually do some operation on integers, right?
Correct.
When you put some integers, you can actually do some operations on integers.
Right.
Okay.
Yes.
Or when you have some something, let's say a character, actually you can find the certain manipulations you can do for a character. Okay. Like you can add 2 characters.
Okay.
Okay. Yeah. See, one character plus another character you can actually add. Okay. Okay. Yeah. But here as such, this structure does not have any sort of functions on it, right? Yeah.
You're saying something?
Function means simply...
in between what you said,
function means simply an operation.
Okay.
Okay. See, my point is...
Yeah.
Did I create any sort of operations around this structure?
Well, not yet.
Not yet. Yeah. Okay. So, I will simply say a scenario, right? Yeah. See, the linked list which you said.
Linked list, yeah.
Right? Yeah. If you create a linked list, right?
Yeah. Okay. Why are you saying linked? It is linked, no? Linked it is called.
Oh, linked. Okay.
Linked.
Okay.
Yeah.
Linked. Okay. Yeah. Linked list.
Yeah.
Suppose if you create a linked list,
yeah.
It is a structure. It is a data structure.
Yes.
But here's the thing.
Yeah.
Apart from having those complex data types,
yeah.
it will also have some operations with it. It will also include some operations with it, okay. Which are in a list.
Okay.
In a list.
Yeah.
Suppose this is a list, right?
Yeah.
So linked list actually looks like this.
Okay.
In a list,
yeah.
You can insert some element in a place, right?
Yeah.
So there is an operation of insertion that can be possible.
Okay.
In a linked list.
Yeah.
There can be an operation of deletion.
Yes.
Could I delete something?
Yes. Yes.
Some node, okay,
yes.
some particular record. I don't want it into mark.
Yeah.
Okay, I don't want it into mark. Just you delete it.
Yeah.
Right?
Yeah.
We could do that. Okay.
Yeah.
So these are called as, so suppose if we create a data structure which has its own operations revolving around it. Okay. Yeah. So that is basically an abstract data type.
Okay.
Of which the definition I have given.
Yeah.
Of which the definition I have given in WhatsApp, you can just refer that.
Oh my god, you already gave, huh? Okay. Okay. Could you just read out the definition, because I cannot access WhatsApp right now.
Okay. Yeah. So I'll read the definition, right?
Yeah.
See, an abstract data type is a high-level description of a data structure. So it's a high-level description of a data structure.
Okay.
So it's not just a data structure.
Yes.
Okay.
Yeah.
Here's the thing. So you will have follow-up questions on data structure versus an abstract data type.
Correct.
What is the difference?
Correct.
Yeah. So, okay. So it is the high-level description of a data structure that defines its behavior, its operations, without specifying its implementation details.
Okay.
Yeah. You get the point? So it's a theoretical concept that defines how data should be organized, manipulated and interacted with.
Okay.
Without worrying about the underlying implementation. Okay. Yeah. So, okay, I'll just modify.
If you give me an example, no? So you mean that abstract data type out of this array, queues and stacks and linked list, abstract data type is only linked list, no? Example is not array.
Abstract data type, yes. Linked list is an example for abstract data type.
But not array and queues and stacks and all.
Array, okay. We can still call it, because technically when you create an integer array, right?
Yes.
Of a square bracket 40, that square bracket does help us to traverse the array, right?
Yeah.
Traverse. So traversing is also one operation. Actually, it's also considered as one operation.
Okay.
Traversing. What do you mean by traversing?
Means like, I think when you search, no? When you search, then you
traversing.
have to go for each slot. Yeah, you have to go to each slot of the array. to search.
Right.
Yeah.
So that is actually provided when you use square bracket. You can index some element of the array, right? You can say 0, or you could say 10, right?
Yeah.
Okay. You could basically say this.
You could traverse
right?
the array. Yeah.
So it could traverse the array.
Yeah.
So that's basically.
Yeah.
Okay. So data structure is, okay, what is not a ADT, I will tell you.
Yes.
What is not an ADT?
Yes.
This is not an ADT.
Struct is not an ADT.
Yes, struct is definitely not an ADT.
Because you cannot conduct operations on it.
Right. So we haven't defined any sort of operations with the structure.
Okay.
Yes. We haven't maybe, see, we said struct person, well and good.
Yes.
We said it will have in age.
Yes.
It will have gender.
Yes.
But could you maybe add even more records? So is there, if we could, could we maybe make some provision which would actually insert even more records? Say, let's say, for the person, right?
Yes.
See, person, I've just plainly defined as this. Yes. But tomorrow, you might even kind of have a requirement to add even more data of the person,
of
right?
Course,
see,
lots of data you need of the person. Lots of data.
What if this is not required? What if this is not sufficient? I have to add the email also of the person, right?
And lot of other details also, yeah.
Right. So this structure does not give us the space to do so.
Correct.
Simply speaking, this structure does not give us a space to do. In a sense, it's not complete.
Yes.
We can say it's not really complete.
Yeah.
Okay. Yeah. When will you say a person is complete? Like when he's able to do something fully, right? Up to the task.
Yes.
So basically, it's like that.
Yeah.
Okay. So a data structure, abstract data type is a high-level description of a data structure.
Okay.
It's a high-level description of a data structure that defines its behavior, its behavior, and also its operations. Okay.
And they say explain its types in the first question itself.
So okay. Wait. And they say explain its types.
Yeah.
Okay. So different types of ADT are there. See, I'll tell you. Okay. Yeah. So different types. Okay, wait.
One is linked list, one is array.
Stack, queue, map, graph. Okay. So different types. What are these? Basically, those which have a hierarchy of data inside them. Yeah. Stack, queue. Linked list also, yeah. So you can say linked list also. Basically, so you have independent. So you will have implementation independence in a sense. ADTs basically can be implemented using other data types also.
So what do you mean by implementation? What do you mean by implementation?
Implementation is suppose some other data should be able to handle. Some other data type should be able to handle what we are giving in an abstract data structure.
Like, can you give me an example?
For example, see, I've created a structure here, right?
Yeah.
Which has some integer and character. Okay.
Yes.
Could you, inside this integer, could you have the provision to now create an array?
Yeah.
No.
Why?
No. Because we only created int age, right?
Yeah.
We haven't expanded it beyond one particular value for the integer. No.
Correct.
Okay, so we haven't provided the provision to do so. But if you see a stack, technically, if you see a stack, right?
Yeah.
So this is a stack, let's say.
Yeah.
A stack is not just, okay, I store some value here, I store some value here, I store some value here. Basically from the bottom, right? Stack means from the bottom we store the values.
Yeah.
Right?
Yes.
So it's not just integers that you can store, mind you.
Right.
This can be flexibly used now to store even a linked list.
Okay.
So this could be a stack of linked lists.
So why I am correcting this linked list, no? Because it will create a very good impression if you pronounce it correctly. Because your English is very good, but only the first time I'm thinking, Arey, why you're saying that? Like, you will be appearing for so many more interviews and meeting clients and so many things you will be doing, no? So
yeah, you are right.
That is why. That is the only reason I am telling you. Others, I have no problem how you pronounce.
I just got habituated the
because
way
you are so like like ace. So then only this should not bring you down. That is why.
No, you are right. You are right. So the way I learned English was usually seeing others pronounce, right? Here's the thing that.
But all the other pronunciations yours is perfect. Only this is I'm first.
Somehow maybe, this probably I might have caught up from someone else.
Correct.
As I'm saying, right?
Correct.
So maybe not worrying too much about how it should.
You can just go through some YouTube video, then you'll get the hang of it.
Yeah, you're right. Okay, so that is one thing. So abstract data type. We completed abstract data type, right?
Yes.
See, that's simple example. If they ask types, just say stack, queue, map, and so on.
Yeah. I'll do that. So one thing, which we forgot, which I had asked you, but we both forgot, is that what is the meaning of return is equal to 0?
Return equal to 0. So here's the thing.
Yeah.
What is this that you have in front of main here? What do you have in front of main?
Int main.
Int main.
Yeah.
Right?
Yeah.
Ever wondered why we are writing this int? I could have just said main, right? Why do you require a... See, you say that this is some kind of a main function, correct?
Right.
So...
No, I'll tell you why we write int. I know why we write int. We write int because the return is an integer. No. Because the return is an integer.
Yes. Correct. I'm just making you ponder.
Yeah.
So, now you understand, right?
Because somebody already told me. That's why I know. Others I won't know. Yeah.
Yeah, because see, every function, we write should have a return type.
But I don't know what is the meaning of return. It doesn't mean closing the program. I'm asking many times. Acha, it means closing the program. Okay, that means if you press 0, the program is closed.
Exit status. It's basically an exit status for the program.
Oh.
Okay. Yeah. So here's the thing, right? When you have processors.
Yes.
Okay. So what happens is when you have processors, right?
Yes.
So there is a lot of data in, data out.
Yes.
Right? In processes. Yeah.
Yes.
Yeah. How do you make sure that some program has exited?
Yes.
Remember, I said 0 was off.
Yeah.
And 1 was on.
Correct.
Technically, 0 and 1 you will use for any sort of binary definitions. See, if I say start, that is a 1. Okay. If I say stop, means that's actually a 0. Okay. So that's where this is coming from.
Okay.
So how do you know in the registries, right? How do you know that a certain program has exited?
Yeah.
So they actually used a key which is logic 0.
Yes.
To say that a certain task is done, Babu, certain task is done, like it is done, over.
Got it.
So they say with the exit status. Actually, the people who have designed C also have done it that way, that this main would exit by returning an integer 0, which would act as an exit status. So yes, right? See, because once it returns a 0, so you now know that the main function is done. It's exiting.
So you will see it on the display.
Right?
You will see it on the display 0.
No. When you return 0, you don't see anything. Rather, you don't see anything.
So when we return 0 means we are going to type 0.
It's going to basically communicate with the compiler that stop compiling.
Means the computer itself will give that 0 communication to the compiler.
Yes.
It is a communication. It is a communication within the microprocessor. We don't have to bother.
Yeah. Okay. So computer does not understand something like a voice command. Okay. Now you stop compiling. No.
Right.
So it's all ones and zeros. Everything. Every kind of communication.
Yes. Then I want to ask you now. We are able to communicate with voice also, no? To Alexa and all. We can communicate by voice also.
Right.
So when we communicate by voice, sir, it is finally converted into the 0 and 1, no? In the microprocessor, it is converted into 0 and 1, no? Finally, because computer can't understand voice.
True.
So finally it is converted into that small electrical signal of 0 and 1.
Yes.
Okay.
So
I understood.
so the sounds so the sounds are basically what are taught to the computer. Like as you said, sound is basically a signal, right?
Yes.
As we speak, sound is basically a signal.
Yes.
That is taught, that is fed to the computer. So
I know how it is. I know because I had worked for a short time many years ago, where the doctors in the US, they don't have the time to write the patient's case history, so they would just speak into it. They would just speak, and that speech would be picked up by the computer, but the doctor had to give a sample of his speech to the computer first, because everybody speaks English differently. Like my English, the computer may not understand. So I had to give a sample of my speech, and then the computer would understand. Then whatever I said, then the computer would, but it would make a lot of mistakes also.
It's like they're making a lot of filter algorithms, which basically identifies every possible accent, I think. But
correct. They already have all the accents with them. Means you don't have to give too many samples. I don't know about that.
Certain signal filters they have to apply. So then you get the actual actual words.
Right.
So but that's okay. What was the next question?
The next question is what are the advantages of using ADTs in programming?
So what are the advantages? Okay, see.
High level description of data structure. The advantages would be that the advantage is that you can make operations, in that data type.
Yeah. So it's basically one thing called as modularity.
Okay.
Means you can encapsulate data.
Okay.
Encapsulation. What is encapsulation? I think you might know better since you are in the field of doctor.
Encapsulation, what we do in medicine is when your immune system, if there is a bacteria or a foreign body, our body's immune system, one immune system cell, it produces antibodies, but there is another immune cell in the immune system that phagocytes it. Means it encapsulates that foreign body and then slowly disposes it off. So in various ways the body's immune system works. So that
capsule, some kind of a capsule we can call it.
Correct.
Same thing. So a linked list as such, or any data structure which you see, kind of encapsulates some data. Even this does this. Even this particular structure does it. So you can see int, age, and character, gender, right? So means you are encapsulating two particular data types.
Yes.
Yeah. Okay. So basically, it encapsulates different types of data. That is one. Implementation, you can also say one other advantage is that implementation, for better implementation, like for example, if you want to do some insertion operation or deletion operation, different operations can be performed.
Okay.
Yeah. That can be implemented better. Yeah, you can say that. Different operations like insertion, deletion, those can be implemented better with the data structures, ADT. One more thing is the modularity. What do you mean? Modularity means like making stuff into like kind of a modular structures, which is encapsulation basically. Okay. So you can encapsulate the data. See, hospital record, you of course want it as an encapsulated data, right?
So what is the opposite of encapsulation? Now suppose you did not encapsulate the data, then what other method is there?
Segregation. I think maybe segregation.
What
you could call it, right?
What is that? I mean, segregation, I know the English word where you segregate the whites and the blacks and all that.
Right, like that.
But in this, how you use the segregation?
Segregation, or it's kind of like segmentation, you can say. Segmenting means what? Everything, you just put it into the basic fragments. Yeah. Right? So, something like that is, so that here as such, here there is no process which actually does any sort of segmentation. You just only have basic data types, right? Like integer, float, character, right?
No, to understand encapsulation, you have to understand what is not encapsulation. Means how would you record data? How would you make this program in C without encapsulation? Without writing int age?
Without encapsulation, I will just write multiple integers. Without C, as I said, Okay, so the basic data, that's where you have to understand the basic. What are the basic data types?
Basic data types are array.
No.
Huh?
No. Int, float, character.
Okay.
Right.
Yeah.
These are your basic data types. Now nothing can be further broken than this.
And data structure is array and all.
Data structure is something. See, for data structure, a general definition I will give you. Data structure is a combination of.
So in this first question, they ask for abstract data type, not data structure.
They directly ask you what is an abstract data type, which is actually, that definition happens only after you understand data structure.
Correct.
Truth is.
Yeah.
So it's actually a combination of different types of data or more number of data. Okay, you can say. Or more quantity, basically. Either in terms of types, or if you have an array, it's just more in terms of quantity, in terms of numbers. So it's you can say also a complex combination. Why? Because you can have a data structure which has multiple data types, right? You can have integer, float, structures. You can create a structure inside a structure. Okay, believe me. You can create a structure inside a mini structure inside a structure. Yes. Like that also people have done. So a complex combination of different data types or the number of data which you can make. Okay, so that is a data structure.